Bismillahirrahmanirrahim. This is Pakistan International School Taif and grade 11, first year, and we are doing chapter number 3rd. Today is 24th lecture, and topic is valence bond theory, and we are talking about sp2 hybridization. Yesterday in the previous lecture, I completed the boron trifluoride example for the sp2 hybridization. Now today we will discuss the structure of ethene. Structure of ethene according to sp2 hybridization. So students, the definition same I will repeat. When one s atomic orbital intermixes with 2p atomic orbitals to give the 3sp2 hybridized atomic orbitals is called sp2 hybridization. Now you have ethene molecule and there are 2 carbon atoms. It means that central atom is carbon, atomic number 6. So electronic configuration is 1s 2s 2 2px 1 2py1 and 2pz 0. So according to this approach, sp2 hybridization or valence bond theory, these 2 unpaired electrons are partially filled atomic orbitals participate for the bond formation. So you done in the sp3 hybridization, we discussed the structure of methane. The same is that carbon has a 4 valence number. So, but this shows the 2. Already we discussed in the previous lecture. You can read these lectures again. So this is called a ground state. This is a ground state. So this is not applicable. What can you do? You have to promote 1 electron from the 2s to 2pz. 2px, 2py, 2pz. So this electron is going to be promoted in the 2pz. So you are seeing that now 4 there are unpaired. So these all 4 participate in bonding, but there the very one important point we will discuss here. In ethene there is a 1 pi bond and 1 sigma bond between carbon and carbon atoms. Sigma bond is formed by the overlapping of straight end to end between the 2 atomic orbitals, and the pi bond is formed by parallel overlapping, or we can say sideways or sidewise lateral overlapping between the 2 atomic orbitals. So if you revisit my lectures, previous lectures, I also told you that these hybridization approach, sp3, sp2 and sp, they only form sigma bonds, not pi bond. Hybridized atomic orbitals only form sigma bond, not pi bond. This pi bond is formed by the overlapping of unhybridized atomic orbitals. So this is called excited state. So when you write the hybridized state, this one as cation is completely filled, it will not participate. And when we are going to do the hybridization approach, mixing, intermixing, so 2s1 plus 2px1 plus 2py1 only. 2pz1 will not participate in hybridization approach. Already I told you this 2pz will form pi bond. So these, when they are going to intermix, according to the definition of hybridization, 1s and 2p atomic orbitals, when they are going to intermix, so you will get a 3 equivalent hybridized atomic orbital, and we call 3sp2. So this is the sp2 one orbital, this is the sp2 second, this is the sp2 third, 3sp2. This is the hybridized. This is unhybridized one, don't write there. This is the hybridized state, and the 2pz1 is called unhybridized atomic orbital. Unhybridized atomic orbital. So 1, 2, 3, you are finding 3sp2, and the structure is the previous boron trifluoride I draw. You can see the structure of this one. So this is the important I told you. 2pz will not participate in hybridization. This orbital form pi bond. For the formation of pi bonding, hybridization process or approach is not involving. Could not involve. That's why it is going to be separated. Now you have a 3sp2 for each carbon. You have 2 carbon atoms. Now look here. This is the carbon number 1, and it has a 3sp2. If you see my previous lecture, same structure I have drawn 3. This is a 1 sp2, second sp2, and third sp2, 3. So you can see between carbon and hydrogen sigma bond means this sp2 is going to overlap with 1s1 hydrogen to form sigma. Second, 1s1 hydrogen sigma, 2 sigma bonds. 1 and 1, there are 2 sigma bonds. These are 2 sigma bonds. Yes, now clear. Now this sp2 of the carbon and sp2 hybridized of other carbon, this sigma bond. This sigma bond. So this is going to overlap sp2 of the other carbon straight overlapping to give a sigma bond. This is sigma bond. Likewise, this again sp2 hybridized for the other carbon. This one. Like this. So overlap with 1s1 for the hydrogen to form this sigma bond. Like this. And the last 1s1 for the hydrogen to form sigma bond. So you can find 5, 1, 2, 3, 4, 5 sigma bonds are there. So each carbon has 3 sp2. Each carbon has 3 sp2. 3 sp2 hybridized atomic orbital. 1, 2, 3. 1, 2, 3. So for the 2 carbon atoms there are 6 sp2 hybridized atomic orbital involved formation of 5 sigma bonds. So there are 5 sigma bonds. So students, this is the formation of sigma bond now. Sigma bonds, they are going to be written in the single line, straight line is called sigma bond. Now how the pi bond is formed, you can see this one. For the pi bonding, you have the 2pz for each carbon. 2pz for one carbon and 2pz for the other carbon. So look here. Again, I am going to write in the bonding formation, students. This is a carbon. Single covalent bond between the carbon. This sigma bond. Hydrogen is there. Sigma bond. Hydrogen is there, sigma bond, and hydrogen is there, sigma bond. So 1, 2, 3, 4, 5. Like this one. This is the same 100%. This is the same. 1, 2, 3, 4, 5 sigma bonds are there. Now 2pz for each. This is the 2pz up below. This is a whole 2pz from here to here. 2pz for one carbon and 2pz for the other carbon. Both here. This is the 2p orbital. Now they overlap parallel. There will be a parallel overlapping between like this, above and below, both above and below to form pi bonds. So now confirm that 5 sigma bond, 1, 2, 3, 4, 5 sigma bonds are going to be formed, and there is a formation of one pi bond which is formed by the 2pz, each carbon unhybridized atomic orbitals. Unhybridized atomic orbitals. So this is the structure of the ethene. And if you see your book, like this. So this structure shows square planar. This is square planar molecule, and these angles 120 degree. 120 degree. So dear students, you have to read whole topic from your book also, and write each and everything from my lecture also. So you can see the same written in the book, and diagram is also same. Ethene molecule is formed by the sp2 hybridized atomic orbitals. The geometry of molecule depends upon the orientation of hybrid orbitals. Hybrid orbitals are the triangular 1, 2, 3, the triangular 1, 2, 3. These three are triangular, planar and orientate with the angle of 120 to each, and one unhybridized atomic orbital left behind, which is partially filled also to be Z, Z, and this orbital involved for the formation of pi bond. Its total structure is square planar, and the angle between the carbon hydrogen is a 120 angle, coplanar, half-filled coplanar. So this is the structure of the ethene molecule, and give sp2 hybridization. I think it's okay. Now, one hybridization approach or process is remained behind. We called sp hybridization. sp hybridization. In sp hybridization, the definition I am telling you, you will see also intermixing of one s atomic orbital with one p, with the ratio 1:1, 50% s character, 50% p character. So s1 and p1 atomic orbitals intermix with each other to give a 2sp hybridized atomic orbitals. So the definition is given in your book. The mixing of S1 s orbital and 1 p orbital of an atom to form two equal, identical, equivalent hybrid orbitals called sp hybridization. So 50% character S, 50% character P each. And ratio is a 1:1. So examples, one is beryllium dichloride, and there is other ethine, acetylene, given in the grade 10. This is the ethine gas or acetylene gas. These are two examples we have for the sp hybridization. And if you see the diagram, so this is the S, this is the one S, and plus P only. Nice. Shape is same. 2sp. 2sp hybridized atomic orbital. If you can see, if you see your book, you can find it. Yes. So there are 2sp. There are 2sp hybridized atomic orbitals. So one is here and other is lines. The two, and they are going to approach with each other. In the beryllium dichloride, beryllium is a central atom with atomic number 4 with number 2 elements, alkaline earth metal. Very first element, very small size of the beryllium. 1s, there are 2 electrons, and 2s, again there are 2. There are no unpaired. There is no partially filled. So according to this electronic configuration, beryllium does not form the bond, any bond. According to the valence bond theory, no partially filled atomic orbital with beryllium. That's why 2px is empty, 2py is also empty, and 2pz is also empty. So because of it is divalent, 2 chlorine atoms are here, so we have to shift 1 electron from 2s to 2px. Promotion of electron. Electron is promoted from 2s to 2px. This is the ground. This is a ground state. This is called a ground state. So, beryllium 4, 1s2, 2s1, 2px1 and 2py and 2pz empty. So you have now 2 partially filled atomic orbital. One is in S and the other 2px. Same definition. This is excited state. Excited state. Now this is the hybridization. One S2 is complete. Now the intermixing. 2S1 plus 2px. Yes. So form 1sp and other s. There are 2 sp hybridized atomic orbitals. Hybridization state. It's confirmed that you have a 2 sp, 1 and 1. 2 only. They are participated. So you can see this beryllium as 1 sp here and second sp. Very clear. Only 2 sp hybridized atomic orbital. Same. This is the same one. No need for writing small, and this is the same if I write here. If I bring here, you will get same, leave this one. If I bring here, you will get same, leave this one. There are 2 sp. There are 2 sp hybridized atomic orbitals straight with the beryllium atom. Now, chlorine, they are halogens. In the halogens, last pz atomic orbital is half filled as we done for the fluorine. Now same is for the chlorine. So this is the 2 for chlorine 3p. 3pZ1. 3pZ1 and sp hybridized to form sigma bond, such as again this is a 3pZ1 overlap with the sp hybridized to form the sigma bond. So students, you can find here straight linear shape, and you done in the Westport theory. The structures are same. You discuss any theory, but the structure should be same, angle should be same, the result should be same. Process different. So this proves that beryllium is a divalent element. Here it should be inert. According to the ground state, you can see this is an inert. But when we discuss the hybridization process approach, so it is confirmed that it is not inert, but it has a two sp hybridized atomic orbital which are partially filled. So when they are partially filled, they participate in the bond formation. So here you can see 2pZ for the one chlorine and 2pZ for the other chlorine. They are participating with the sp hybridized atomic orbital to give the linear shape of beryllium dichloride. Straight shape, linear shape. Beryllium dichloride has a linear shape. So this is the beryllium, and there is a chlorine here, and like this one. And angle is 180 degree, and shape is linear, straight, proved. So dear students, this is the sp hybridization approach, and we completed the beryllium dichloride molecule, and explanation is given here. Note it, write it, very important things are we are discussing here in the modern theories of bonding. So in the beryllium dichloride, you can see here, same is written also, 2s and 2p orbitals of beryllium intermix with each other to give the two Hubbard orbitals. Each Hubbard orbitals contain one electron. Each Hubbard orbital contains one electron, sp and sp, and they are going to overlap with the 3pZ for chlorine on both sides, which is given also here to form a sigma bond between the beryllium and chlorine. So 2pZ for the chlorine and chlorine, they are going to form a sigma bond. So angle is a 180 angle, and the structure is called a linear structure. So dear students, here we completed one example of the sp hybridization. So already I told you, when you are going to listen carefully the lectures, see the topics very well, and the questions you have to mark, see the exercises questions also, solve them very well, and do very well, very nice and neat and clean, and you have to write each and everything here for your examination. So dear students, we are going to stop here. Only the one example is going to remain behind for the sp hybridization, that's called acetylene or ethine. So already I told you in the previous lectures, in the grade 11 and 12, every chapter is different from other. Especially in the grade 11, all the chapters are different. If you see first chapter, second chapter, third chapter, we are different. No connection with the previous chapter. That's why all the chapters they need for hard working, full concentration. Then you can learn. So thank you very much. Today lecture is stopped.